Hi guys. In this video, we're going to be revising the section of factorizing going into grade 10. And you might be used to a few methods of factorizing that you would have done in the previous year. And the first form of factorizing that you would have come across was known as taking out a common factor. That's where if you have an expression and they all have something in common, then you just pull that out and put everything inside the brackets. Remember, factorizing is the opposite of the product section, which was products was breaking the brackets. Factorizing is putting the expression into a set of brackets. So common factor was the first and probably the most important one that you need to remember. The second one was known as difference of two squares or dots. The third one that you would have learned is how to factorize a trinomial. And there are other forms that you will see in, I'll probably end up doing future videos on this, and that is factorizing cubic expressions or cubic functions, and also group factorizing. Grouping is, to be honest, it's just a fancier form of taking out a common factor. So let's start with taking out a common factor. That's the easiest one. That's the one that you should be the most familiar with, and this is the one that you always try first. It's always the one that you look at first. This one takes preference over all the other forms of factorizing. So if I look at this expression, we have an x and a 2 that can be common with all three terms in this expression. So I'm going to pull out a 2x. Remember, if the instruction says factorize, it is asking you to factorize fully. So yes, I could have just pulled out an x from all three terms, but that is not factorizing it fully. I needed to bring out the 2 as well. So if I pulled out a 2x, I would be left with 3x squared plus 2x plus 1. This 1 is extremely important. Please don't forget about it, because if you have three terms in your original expression, you need to have three terms within your set of brackets. And the way that we can double check our answer is to just redistribute the term that we pulled out back into the set of brackets. So 2 times 3x squared is 6x cubed. 2 times 2x, excuse me, will give me 4x. And 2x times 1 will give me 2x. You don't have to do this, but this is a way of checking that our factorizing method is correct. Okay, let's move on to the second example. Well, we have a whole bunch of x, y's, and a couple of exponents here and there. So if you look carefully, the most number of x's that we can pull out is an x squared. There's an x squared, yeah, and yeah. And the most y's that we can pull out, the maximum number of y's will be a single y. And we put everything else inside the brackets. Well, if we pull out x squared y from this expression, we would just be left with a 2. If we pull out x squared y from this expression, we'd be left with just an x. And with the final expression, we'd be left with just a y. Again, we can redistribute this into the terms inside the brackets, and we should end up with the initial expression. Okay, let's move on to difference of two squares. Well, difference of two squares, please remember that difference in mathematics means subtract. So if there's an addition, excuse me, at any time if you are given an expression and it contains an addition, you can't apply difference of two squares. That doesn't make sense. So this is the standard formula for difference of two squares. You have two squares that are being subtracted from one another. And the stock standard formula is that you square root each term and you put it into a duplicate set of brackets, but the only difference being that one set of brackets must contain a positive and one must contain a negative. It doesn't matter what order you put this in. You can put the negative this side or the positive that side. Okay, so let's jump straight in. This is the skeleton that we'll be following for difference of two squares. Let's jump straight into an example below. We have 4x squared, 4x to the power of 4 minus 9 to the power 9y to the power of 4. And this is where people start getting it a little bit wrong. They forget to actually square root the number. They forget to square root the number. Well, the square root of 4x to the power of 4 is equal to 2x squared. And on the other hand, the square root of 9y to the 4 will be 9y squared. So in other words, I'm just going to open up my set of brackets, because this is how dots will always be structured. You'll always have these two brackets. Well, one will have a plus, one will have a minus. And I simply take the square root of this, which is 2x squared, and the square root of this, which is 3y squared. And I will do the exact same on this side. Easy. Just be careful when doing a dots, because if you take a look at this bracket, if this was another difference of two squares, you would be required to write out a second group of brackets. So obviously you can't do it to this set of brackets because there's a plus, but this set of brackets could be another difference of two squares. It wouldn't be in this case because 2 and 3 are not perfect squares. But if this was a 4x squared minus, 9y squared, we could refactorize that. We could re-dots that. So that's a nice little trap that your teachers will probably set for you in exams and tests. Okay, so let's just move on to trinomials. Now, trinomials take on the same form as dots. They take on the same form as dots, where you have two sets of brackets, but the pluses and the minuses are not as straightforward. For trinomials, we look at the lead at the constant term, which would be the 12 in this case. The sign doesn't really matter too much. It's more just this number that I'm interested in. And you list the factor pairings of 12. Well, we have 1 and 12, 2 and 6, 3 and 4. I need to look at this value. I call it the b value. I just refer to that because in quadratics, that's what this is referred to as, the b value. The b value is positive 7. Remember I said that the 12 sign, you don't have to worry too much about, but the b value sign, this sign is extremely important. We need to get a positive 7 by using these factor pairings. How can I minus and add these numbers together and get a positive 7? Well, 2 and 6, that doesn't really give me a 7. 1 and 12, definitely not. 3 and 4, I could do something there. I could go plus 3, plus 4, gives me a plus 7. Obviously, the x's follow the same suit. The x's follow the same suit. Again, like before, you could actually FOIL this out, and you should get an answer equal to the original expression. Okay, if we look at the second example. Now, this is a little bit of a trick question, because a student would be tempted to just apply trinomial methods to this expression, and that would actually be incorrect. Remember I said the common factor method takes preference over all other factorizing methods. So that is the method that you need to look for first. Is there a common factor between these three terms? Yes, there is. There is. The common factor would be 2. So I'm going to go ahead and use a big set of brackets. I'm going to pull out a factor of 2 and say that I'm left with x squared minus 7x plus 12. Okay, it's almost identical to the previous example. Now, we're not done yet. This is now a trinomial. It's a potential trinomial. A lot of students would have tried to apply the trinomial method to this original function and would have just ended up getting it completely wrong. So please don't forget the 2. If you leave out this 2, it's actually mathematically incorrect. You are most likely to get a mark taken off because of that. So this is the way I'll set it out. I like using big brackets. Big brackets make it look so much more superior, if you could say. So same as before, we're going to look at the leading factor, we're going to look at the constant factor, sorry, and get the factor pairings out of it. It's actually the same as before because we did the 12 in the previous question. Well, how do I get minus 7? Minus 7. Remember in the previous one, it was positive 7. This is a minus 7. This changes the game. This does change the game. Not too much. Because again, 2 and 6, you can't make it 7 with 2 and 6. You can't make a 7 with 1 and 12. It has to be the 3 and the 4. It has to be the 3 and the 4. It needs to be a minus 3 minus 4. And that would be your final answer. Again, please do not forget this 2. This 2 is hectically part of this expression. So I know I mentioned cubic functions and grouping. I will probably end up doing a separate series of videos on that. In the meantime, thanks guys. Thanks for watching. And stay tuned for the next one.